All right, let's talk about data. You've seen it, right? A long list of numbers. Maybe it's test scores or house prices or whatever. And you're just staring at it thinking, okay, but what's the one number that really sums this all up? Well, today, that's exactly what we're going to find out. I mean, that's the big question, isn't it? When you're faced with just a mountain of data, how do you boil it all down to one single value that actually represents the whole group? It's really the core challenge of making sense of information. So there's a fancy name for this, of course. Statisticians call it measures of central tendency. All that means is it's a way to find the center point, the value where the data tends to cluster around. And we're going to break down the big three: mean, median, and mode. Okay, so let's kick things off with the one you're probably most familiar with, the mean. You might just call it the simple average. Yup, the mean is pretty much what we all think of as the average. And the math is super straightforward, right? You just add up all the numbers in your list and then divide that total by how many numbers you had to begin with. It's the classic, the go-to for numerical data. So let's try it out with a really simple set of numbers. We've got 2, 4, 6, 8, and 10. First step, just add them all up. So 2 plus 4 is 6, plus 6 is 12, plus 8 is 20, plus 10. That gives us a grand total of 30. Okay, so we've got our sum, which is 30. Now we just divide that by the number of values we started with, which was 5. And 30 divided by 5 is 6. So for this nice little data set, 6 is our mean. Easy peasy, right? But what happens when the data isn't quite so perfect? And this is where we get a plot twist. See, the mean has this one major weakness, a fatal flaw, you could say, that can make it totally misleading. It's what we call the outlier problem. So here's the deal. An outlier, that's just one single value that's either way, way higher or way, way lower than everything else. It can completely wreck the mean. Just think about a company reporting its average salary. If you have 100 employees making around 50K, but the CEO makes 5 million, well, that one massive paycheck is going to pull the average way up, making it look like everyone's rich. That's an outlier in action, and it's a huge problem. Okay, so check this out. On the left, that's our original, nice, balanced data set. But on the right, look what we did. We just tossed in one single outlier, the number 100. So what do you think that one little number is going to do to our nice average of 6? Whoa, the new mean skyrockets to 21.67. We went from 6 all the way up to almost 22. Now, be honest, does that number really represent a group of numbers where almost everything is 10 or less? No way, not even close. That one outlier completely distorted the picture, and that tells us we need a different tool for this kind of job. And that tool, my friends, is the median. You can think of the median as the hero that swoops in to save the day when you've got those pesky outliers. It's specifically designed to find the true middle ground, no matter how crazy things get on the high or low end. Now, the definition here is super, super important. The median is the middle value of a data set. But, and this is a big but, only after you've put all the numbers in order, from smallest to largest. You absolutely cannot skip that step. It's the whole secret sauce. It's what makes the median so powerful against those outliers. Okay, let's look at a simple example. Say we have the numbers 1, 3, 5, 7, and 9. Good news, they're already in order for us. With 5 numbers, finding the one smack in the middle is easy, right? It's 5. That's it. The median is just the number that's physically in the center of the line. Okay, but you might be thinking, what if there's an even number of values? Then there's no single middle number. And you're right, but it's no big deal. So look here, we've got 6 values now. We find the 2 numbers in the middle, which in this case are 5 and 7. All you do is find the average of those 2. So 5 plus 7 is 12, divide by 2, and our median is 6. Simple as that. All right, so we're getting pretty good at this. We know how to handle nice, clean numerical data, and we know what to do when there are outliers. But what if our data isn't even numbers to begin with? Well, that brings us to our third and final tool. I mean, think about it. How would you find the average favorite color from a survey, or the average answer to a yes or no question? You can't add blue and red and divide by 2. It just doesn't work. This is a problem that both the mean and the median are totally useless for. And the solution is the mode. The mode is beautifully simple. It's just the value that shows up the most often. That's it. The most popular choice, the most common item in the whole dataset. It's perfect for what we call categorical data, like colors or names, but hey, you can use it for numbers too. Let's look at this set of numbers. To find the mode, we just have to count. So, let's see. The number 2 appears once, twice, 3 times. The number 4 shows up twice. And everything else, 3, 6, and 7, they just appear 1 time each. Well, since the number 2 showed up more often than anything else, our mode is 2. It really is that simple. Now, a quick heads up, a dataset can actually have more than one mode. That's if there's a tie for the most frequent value. And it can even have no mode at all if every single value appears the same number of times. Okay, so we've gone through the mean, the median, and the mode. Now for the most important part of all, knowing which one to use and when. This is the key takeaway. And this chart really lays it all out for you. It's your cheat sheet. Basically, if you have numerical data and there are no crazy outliers, the mean is your best bet. But the second you see those extreme values, you've got to switch to the median to get a more honest picture. And finally, if you're not even dealing with numbers, if you have categories like favorite foods or survey answers, then the mode is the only way to go. Simple as that. So I want to leave you with this one last thought. The next time you're reading a news article or you see a report and they mention an average salary or an average house price, what's the very first question that should pop into your head? You got it. Which average are they talking about? Is it the mean, the median, and more importantly, what does their choice tell you about the data they might not want you to see?